Hello everyone, we are from Al Marifa International Private School, Thermal Physics, IGCSE 0625. Our learning objectives. We are going to solve some selected questions from Thermal Physics of past paper 4, 2015 until 2019. Now, to answer short questions from past paper 4, this paper is designed to test the knowledge and understanding of physics theory, and also the ability of the students to apply the concepts of physics in different situations. So here we have some basic guidelines to solve this paper. I'll give you some guidelines. First one, do not repeat any fact given in the question set. You must answer the question directly. Second one, if you are facing any problem with any question, you have to leave it and mark this question. Then you can come back to this question later. So maybe you will find it easy to answer. Also, I have other guideline. Don't waste your time and write a long answer to a question which has 1 or 2 marks. You will not gain any extra mark even if your answer is full of many correct statements about this question. Also, the number of marks will guide you on how long to spend on each question or part of a question. Now, if a part of the question is worth 3 marks, for example, you should make at least 3 separate points. But be careful not to make the 3 same points 3 times. No marks are awarded for the repeated points. Now, if a question is require a drawing diagram, you must draw it with a ruler and label it with small straight lines. Last one, please be familiar with the features of your calculator because we need it in solving the calculation questions in physics. Now let us start with question number 1. As you see in question number 1, we have, this is a question from 2019. A solid has a fixed shape. Now liquids adapt to the shape of their containers. Gases fill their container. Now explain in terms of forces between molecules and arrangement of molecules why solids, liquids, and gases have the same these properties. So as you see here, we have 6 marks, 2 marks for solids, 2 marks for liquids, and 2 marks for gases. So we have to list 2 ideas for solids, 2 ideas for liquids, and 2 ideas for gases. Let us to remember about the features of solids, liquids, and gases. Now, in solids, the intermolecular distance is extremely small. They are close to each other. And in liquids, the intermolecular distance is greater than solids. So they are farther apart from each other. In gases, the intermolecular distance is very wide, more than solids and gases. Regarding the intermolecular force, in solids, the intermolecular force is very strong. The attraction force between molecules is very strong. And the intermolecular force of liquids is weaker than solids. And the intermolecular force for gases is very, very weak. It is negligible. We can cancel it. It seems there is no any force between gases molecules. Let us to see the answer of solids. So we can say that solids molecules, they are in lattice arrangement. and also they have a strong intermolecular force between them. Here is one idea, and here is the other idea. For liquids, we have a lot of ideas. We can choose two of them only. Molecules are not in a fixed place. They can change the shape, and also molecules, or we can answer molecules have a regular irregular arrangement, or the spaces intermolecular distance of molecules of liquids greater than intermolecular distance of molecules of solids. Now the forces too weak to keep molecules in a definite pattern. Now the force just enough to hold molecules in a plug and of the liquid. Now for gases. Now in gases, molecules are far apart, and also the no force between molecules. As we said, we can cancel and negligible the forces between molecules of gases. Here are the two ideas, one about the intermolecular distance, and the other one about intermolecular force. The second part of the same question, explain in terms of molecules why it is possible to compress a gas but not a liquid. So in this case, how many marks we have here? We have 2 marks. We have to list the reason for why the gas are compressible and why the liquids are not compressible. Now the answer of this one. So in gas molecules, they are far apart. They have enough spaces between them. So that's why they are compressible. And liquids, the spaces, they are not enough to compress them. This is the answer of question number 1. And you can see also intermolecular distance of molecules of gases is very wide. So that's why they have spaces. Lets them to be compressible. And liquids, the spaces or intermolecular distance is smaller, so there is no spaces to let the liquid to be able to compress or to be compressible. Now the second question B, 2 containers made of insulating material contain the same volume of water at room temperature. The containers do not have lids. The volume of liquid in each container gradually decreases. Now, I1. After a certain time, the temperature of the water has decreases to below room temperature. Explain in terms of molecules why the temperature has decreases. So as you see, we have to list ideas why the temperature of the containers decreases after some time of leaving the container at the room temperature. The 2 ideas we learned about the evaporation that happens at any temperature. So evaporation is the purpose of decreasing the temperature. So because of evaporation, the most energetic molecules from the surface of the 2 containers will evaporate. After some time, the rest of the molecules in the container will have less kinetic energy. So by this way, the average of kinetic energy, which is temperature, will be lower than before. This is the 2 ideas, one about evaporation, one about the rest of molecules that have less average of kinetic energy. So the temperature gets lower. The third question, one of the containers is wide and shallow. The other container is narrow and deep. Now, predicate which container has the greater rate of cooling. Explain your answer. So as you see, we have to choose one of them. It has 1 mark. The explanation also other 1 mark. Now, for sure, we learned about the factor of rate of cooling. The wide and shallow one has a greater rate of cooling. And the reason that larger surface area, yes, the answer is this one. So we have to choose the shallow and wide one that has larger surface area. So the reason the container has 1 mark, and the reason larger surface area, so the rate of evaporation will be higher or faster. This is the second mark. Let us now to move to question number 2. You can stop the video and answer by yourself, then check your answer again. See this question now. In this question, as you see, a student is studying the motion of dust particles in a dark dust room using his torch, with produces a high intensity light beam. He records the temperature of the room using his digital thermometer, and it was 20 Celsius. Now, dust particles are seen as tiny specks of light. Question number 8. In this space below, draw a diagram to show the motion of one of the specks of light over a short period of time. Now, this is the drawing, as we said in the previous lesson. We have to draw the Brownian motion, at least 3 straight lines with changing direction. Don't forget the arrows. It has 1 mark, but sometimes they put 2 marks. So here it is 1 mark. It's okay. Let us to see the correct one with your ruler. Use your ruler. Draw at least 3 straight lines with changing direction. Don't forget the arrows. So here is the dust particle. After collision, it will change the direction to this side, then to this side with arrow, then to this side with arrow. I put 3 other lines. It's okay, but this is the correct shape to gain the 1 mark. Let us to see the next branch of this question. After a couple of hours, the specks are still observed, showing that the dust particles have not fallen to the floor. Explain why the dust particles have not fallen to the floor, and you may draw a labeled diagram to help your answer. Now, this label diagram, you will not gain any mark for it. The marks will be on the answering here, but it's okay. It will help you to answer the question. So as you see this question, why the particles have not fallen to the floor after some time. See the drawing. As you see here, we have the air molecules. Here we have the dust particles. After collision, the motion will be up. Then after collision, it will be down, then left, then right. It will keep continuous in a random motion. And this is because of collision between air molecules and dust particles. Now the answer, the tiny fast-moving air molecules hit the large, heavy, and slow dust particles randomly in all directions. So they have up as well, they will move also down. So the 2 marks, the collision itself between which 2 particles? It will be between large, heavy air molecules and also large, heavy, and slow dust particles. And this motion will be randomly and on all directions. This is the second mark. So to describe the motion between which 2 particles, then the feature of this motion, which is randomly in all directions, you will gain the other mark of this branch. Let us to move to the third branch of this question. On another day, the temperature of the room is only 10 Celsius. All other conditions are the same, and the specks of the light are again observed. Suggest any difference that you would expect on the movement of the specks when the temperature is 10 Celsius compared to before. As you see, what is the change in this situation of the question? The temperature only. The temperature before is what? Is 20 Celsius. The temperature now is 10 Celsius. So as you see, we have to list one change only on Brownian motion when temperature decreases from 10 Celsius to 20 Celsius. The answer will be that the random movement of the bright specks will be seen shorter distances and slower. than the at a higher temperature. So the Brownian motion will get slower, the straight lines will get shorter because the temperature decreases. Now let us to move to question number 3. And question number 3, as you see, we have the cylinder. This cylinder is filled with what? With oxygen. So we have a sealed steel cylinder filled with a high temperature oxygen. So the pressure inside, is high. And we have a gas of oxygen inside. They need in branch A, describe the movement of the molecules in the high pressure oxygen. So we have to list 2 ideas about the movement of oxygen inside at high pressure of oxygen inside the cylinder. So we have to list 2 ideas. First one about the movement of gas, then about the collision of gas with the wall to exert this high pressure. So in the gas state, the molecules move randomly in all directions at high speed, with high speed between the collision with the walls of the cylinder. So since the molecules of the gas, they are moving randomly in all directions, so the collision with the wall will be at high speed. This will describe the high pressure of oxygen inside the sealed cylinder. The other branch of this question, B, explain how the oxygen molecules exert a high pressure on the sides of wall of the cylinder. As you see here, we have to describe the procedure of high pressure. How? We know that pressure is equal force over area. So when the oxygen is exerting a high value or magnitude of force by hitting the walls of the container, this will increase the pressure. Since the relation between pressure and force is directly, so the hitting of the walls of the container strongly and frequently, this will exert large force, then after increasing the force, for sure the pressure will be high. So we have 2 ideas. By hitting the walls of the container strongly and frequently, they exert large force on the inner walls of the cylinder, causing high pressure. So 2 ideas: the hitting itself is strongly and frequently, and this will exert more force. This is the second idea, to have a high pressure by this oxygen. Now, question number 4. Now, let's state 2 differences between evaporation and boiling of water. So as you see, we have 2 marks. We have to list 2 ideas about evaporation and boiling in first one, and other 2 ideas about evaporation and boiling in the second one. We have a lot of differences between evaporation and boiling. We can choose any 2. Let us to see what is the technique to answer this question. Evaporation is for surface molecules, but boiling is for all molecules of the liquid. Second point, evaporation happens at any temperature below the boiling point, but boiling happens at the boiling point exactly. So as you see in the first point, we list 1 idea about evaporation as well about boiling. In the second point, we listed 1 idea about evaporation as well about boiling. This is how to gain the 2 marks of this question. Let us to see this calculation question. Now, an air blower is operated by the compression of air. Now, the air inside the air blower cylinder has a pressure of 1 × 10⁵ Pascal and a volume of 180 cm3. When the air blower is operated, the volume is reduced to 50 cm3. The temperature of the air remains constant during the process. Calculate the new pressure of the air inside the air blower cylinder. Now they need the pressure after doing the changes on the cylinder. Let us to remember something about this question. We learned about Boyle's law and the relation between pressure and volume. As you see here in the figure, we learned when you move the handle up, volume increases and the pressure decreases. When you move the handle down, volume decreases and pressure increases. So we have inversely relation between volume and pressure. Now the Boyle's law states that the pressure times volume before changing is equal to the multiplication product of pressure after times volume after. So P1 times V1 is equal P2 times V2. So the multiplication result of pressure times volume before moving the handle is equal to the multiplication product of pressure and volume after moving the handle. So it is constant before and after. So as you see how we will use this fact. Firstly, underline your givens. We have P1 and V1. We have V2, but they need us to what? To calculate the new pressure, which is pressure 2. Let us use the formula. P1 V1 equal P2 V2. After substituting all of the value, for sure we need P2. Just multiply 1 times 10 power of 5 times 180 over 50. The answer will be 3.6 times 10 power of 5 Pascal. We have 2 marks here, 1 mark for this procedure and 1 mark for the answer, magnitude and unit. Don't forget the unit. This is the way to answer this type of calculation question. Let us now to move to question number 5. And question number 5, as you see, we have this apparatus cube, which is to be used to compare the emission of infrared radiation. Here it is from 4 differently painted surfaces. As you see, we have this surface that is painted with shiny black, this surface that is painted with dull black, and this one that is painted with shiny white, and this one painted with dull white. Now, also there are 4 infrared detectors, so that each detector is facing the center of one of the 4 sides. Now describe how you would use the apparatus to compare the infrared radiation from the 4 surfaces. Let us to remember this experiment by this slide. As you see here, we have the 4 faces. This is we have to place first one the 4 detectors with equally distances from each face. Then we have to fill the container with boiling water. Then we have to wait some time interval equally between the 4 detectors. Then we have to collect our data from the ammeter that is directly attached to each detector. Then we have to convert the data we got it from the ammeter. Then after we have to decide which phase is best emitter and which one the categories of the 4. Now the answer of this one. So now the name of detector is thermopile. So we have 4 detectors or 4 thermopiles. Now use thermopiles to take the reading of each surface. Now both the thermopiles of equal distances from each surface. Then fill the cube with hot water. Then compare the data that is appear from the ammeter that is attached to the detector. So as you see, first one we have to place the detector from equal distances from each face. Then we have to fill the container with hot water. Then last we have to compare the data given by the ammeter that is attached with each with each detector. This is the question number A. Now, second branch of this question suggests which surface will be the best emitter and which will be the worst emitter. Now, from our previous lesson, we learned that the face that is matte black or dull black is the best emitter, as you see represented by these arrows, and the shiny one is the worst one, as you see represented by one arrow. So the answer, best emitter, dull black or matte black, and shiny white will be the worst emitter. Now let us to see question 6. In question 6, as you see, we have one side of a copper sheet is highly polished and the other side is painted matte black. Now the copper sheet is very hot and placed in a vertical position as shown in figure 5.1. Now a student places her hands at equal distances from the sheet. So as you see, here is the figure in 5.1. What we need here, we need to explain why her hands are not heated by convection and why her hands are not heated by convection. For I1, we have 1 mark, I2, we have 1 mark also. We have to list one idea here and one idea here. Why do you think the heat does not transfer to her hands by convection and by conduction? We know that the air is poor conductor, so that's why the hands are not heated by conduction. Now convection, we know that the heat that released from the surfaces will make the air less dense, so this air will warm up and it will move up. So this is why the heat does not transfer to the hands. First one, convection is not there because the warmed air raised up because of its density that is less than the cold air. And conduction, already air is poor conductor, that's why. Now in the third branch, which is B, state and explain why hands gets hotter. Which hand gets hotter? The one that is facing the matte black side or the one that beside the polished side? Let us to see the answer. The answer should include 2 ideas. First one, the hand that will get hotter first or more is the left hand, since this hand is facing the matte black face, and we know that the matte black surfaces, they are best emitters to the radiation. So 1 mark for choosing which hand, so the answer will be left hand. The other mark, the reason, because of matte black surface that is classified as best emitter of radiation. Now let us to move to question number 7. See, in question number 7, we have this figure of that is showing a cross section of a double-walled glass vacuum flask containing a hot liquid. Now the surfaces of the 2 glass walls and the flask have a shiny silver coating. Now in A, explain why the rate of loss of thermal energy through the walls of the flask by conduction is very low. Why do you think these 2 layers of glass walls will help to reduce the conduction from the flask? So the answer, that the vacuum that is captured between the 2 walls is poor conductor. Other idea, that the glass itself is poor conductor. So this is the answer of this question. Second one, why the rate of loss thermal energy through the walls of the flask by radiation also is very low. So the answer of this one, we have to list 2 ideas. First one, that the silvery color is good reflector, so it reflects most of the heat back into the flask. Also, it is bad absorber and bad emitter of radiation, so a very few amount of heat can escape from the flask. So two ideas, one about the surface that is silver, which is good reflector, and also the silvery surface that is good, poor emitter. These are the two ideas of the question. Now let us to see question number 8. Now in a question number 8, this figure shows 5 vessels, each made of the same material and containing water. Now the temperature of the air surrounding each vessel is 25 Celsius. See now this table about details of the 5 vessels. In vessel A, the outer surface is dull, volume of water is 200 centimeter cube, and the starting temperature is 80. Now the vessel B, the outer surface is dull also, volume is 100 centimeter cube, and the starting temperature is 80. C also dull, the water volume is 200 centimeter cube, and the starting temperature is 95 Celsius. Now in D, it is shiny surface, and the water volume is 200 centimeter cube, and the starting temperature is 80 now Celsius. In E, it is dull surface, the water volume is 200 centimeter cube, and the initial temperature is 80 Celsius. Now, temperature of water is in each vessel will fall by 15 Celsius degree. Now, explain why water in B more quickly cools more quickly than water in E. Now, why do you think? What are the variables that are constant between B and E? Both are dull surfaces. Now, both they have same starting temperature, but the volume of B is 100 centimeter cube. Volume of water in E it is 200 centimeter cube. So we have to start our answer from here, from the volume of water. Remember what we explained about the volume of water, quantity of volume of matter, and cooling rates. So the answer is what? B has less amount of liquid, so has small amount of heat to lose. That's why it's B cools more quickly than E. And this is the reason. Now, in a question, second one of the same, second branch of the same question, suggest two reasons why the water in A cools more quickly than the water in E. A and E, both are dull, both they have same volume of water, and also both they have same starting temperature. We have to go back and to look to the surface area between the two containers, A and E. As you see, in A, we have large surface area. In E, we have a small surface area. But they need two ideas. The losing of thermal energy will be from two sides here. One from evaporation. Since we have large surface area, so we have more molecules to escape from the surface. So this will help to make the rate of evaporation more. Now, the other idea here that the surface area of the container is more, so the conduction with the surrounding will be more. That's why the conduction will be greater in A than E. So the two ideas, A has large surface area, so faster rate of evaporation, and the greater heat loss by conduction from this large surface area. This is the answer of this one. The second branch explain why the water in D takes longer to cool than E. D and E. Both they have same starting temperature, both they have same volume of water, but D is shiny and E is dull. Now the answer will be from here, shiny and dull. So our answer will be dull surfaces. They are better emitting of radiation, and bad reflector, so heat can escape easier than the shiny one. This is the answer of this question. Last one, explain why the water in C cools more quickly than A. C and A, both they are dull, both they have same volume of water, but the starting temperature of A is 80 and C is 95. So C cools more quickly than A because of this, because of starting temperature. Now C has higher temperature, so faster rate of evaporation and the greater temperature difference with the surrounding. This is the reason for this question. Let us now to start with the question number 9. See, in the question number 9, we have this apparatus that is a differential air thermometer. So see the structure of this apparatus. We have a glass bulb that is painted with a matte black, and also we have other glass bulb that is painted with silvery color, and we have here the radiator that is placed with equal distances from the bulbs, and we have this tap that we can fill the water inside. Here is the tubes. And here we have air, here we have water. So the heater is switched off. Now the tap is opened, so the air on the two sides of the tap has the same pressure. Now and water level is the same, tap then closed. Now the heater is switched on after this procedure. On the figure. Now mark clearly where the two liquids after switching on the heater. We have to mark clearly where the two liquids levels might be a short time later. So after switch on the heater, we have to draw other two levels of water. So our answer will be same this. This level of water will decrease until here, and this level of water will increase until here. What is the reason? As you see, we have here a bulb that is painted with matte black, and this bulb painted with silvery color. So as you see, the black bulb will absorb more of heat. So the air here will gain more of thermal energy. So air will expand. Then this air will exert a pressure on water. Let's it to decrease its level until this side. As well, the water will raise from the other side here. This is the answer. So on the left hand side, the black bulb absorbs more of heat energy, so temperature of the trapped air increases quicker and expands greater than the other side, which is silvery bulb. So this air that in this side will gain more of thermal energy. It will expand, then it will exert a pressure on the water. Let's it is level to decrease, and the other level of the other vessel here will increase of the water. This is the answer of this question. Let us now to move to question number 10. In question number 10, as you see, we have some students are in a summer camp for 1 week. They have a good supply of water, but unfortunately, they forgot to bring their small refrigerator. Now, they have a bottle of juice or milk that must be kept cold. They covered the bottle with a damp cloth that is dipped inside water as shown in the figure. See what they did to keep inside bottle liquid at a low temperature. Explain in terms of molecules why this idea would be successful. So as you see, the water will raise from this side to this side. It will fill the cloth from this side. Then the most energetic molecules will start to evaporate from where? From the clothes. This will help to decrease the temperature of liquid. As the temperature of this liquid decreases, the heat will transfer from inside the bottle, from liquid, from milk, from juice, to the water. This will help to cool down the liquid inside the bottle. And the procedure will continue to keep the liquid or juice at a low temperature. So this is the idea of the question. It has 3 ideas, 3 marks. When water in a damp cloth evaporates, the highly energetic molecules escape, leaving the less energetic molecules behind, so the temperature decreases because of evaporation, and the milk will be in a low temperature. This is the idea of the question. It is a nice idea. So we are now in question 11. Let us to see question 11 that is connected with the question 10. It is the same, but we are talking here about other factors. So as you see, we have 2 containers from 2 different sizes. So the size of this one is large surface area. The size of this one is a small surface area. Water in both dishes start to evaporate. Explain why water in the large dish dries out more quickly or rapidly than the water in the small dish. So it has 2 ideas. We have to connect the idea of surface area and evaporation. Let us to remember this idea. We learned that when the surface area is more, we have more molecules. So in this case, we have more energetic molecules to escape from the surface. In this case, the more molecules can escape from the surface at the same time. This will increase the rate of evaporation. So in this case, the rate of evaporation will be more from the large surface area. So see the drawing here, we have more molecules, less molecules. For sure, I will have more energetic molecules than here. So the answer will be larger dish has a greater surface area. This means that there are a greater number of molecules of the surface which are likely to escape from the surface. This is the idea of this question. Let us to continue. State 2 changes that would make water evaporate more quickly or rapidly. So we learned a lot of procedures to increase the rate of evaporation. Just we have to choose 2 ideas to listed in this question. I choose these 2. Air current over the surface. If we increase the air current, the rate of evaporation would be more. And higher temperature also can increase the rate of evaporation. Let us now to move to question number 12. See in question number 12. In question number 12, we have this figure 6.1 shows an experiment to observe the motion of smoke particles in air. And in AI figure 6.2 shows the view through the microscope of one smoke particle labeled P. On figure 6.2, draw 3 lines to show the movement of this particle. It has 2 marks. We have to draw 3 lines with different directions. Don't forget the arrows. This is the way to gain the 2 marks here. Here is the answer. 3 straight lines joined together at the end. Don't forget to change the direction. 1 mark for the 3 straight lines, 1 mark for the changing and directions. The second question here, we have to explain this motion itself. It has 2 ideas. The motion produced by the collision between the air particles and the smoke, large, slow smoke particles. And this is collision caused to move the particles in this randomly small straight line, which is called Brownian motion. Branch B, the air containing the smoke particles becomes warmer, suggests how this changed the movement of the smoke particle. So the surrounding air now becomes warmer. How do you think this will affect the motion of Brownian motion in this case? Now the answer, we will have more collision, more change in direction, also the straight lines will get longer than before. It has one idea. You can list any idea of these. Let us now to move to question number 13. See, in question 13, we have figure 7.1 shows equipment used to demonstrate thermal expansion. So we have a copper rod that is attached to a pointer and ruler, and also we have support, and the rod is already fixed, attached to a fixed block. The idea of question number A, question of letter A, the copper rod is heated and expands. It turns the ruler and moves the pointer. Now, on figure 7.1, draw the new position of the pointer. So we have to draw on the figure itself what is the new position of the pointer after expanding the copper rod. So the answer will be, after expansion, it will move to the left, or we can answer anti-clockwise. You can draw anti-clockwise arrow, or you can write to the left. Now, second question, as the rod is heated, some of its properties change. Now, identify how each property changes. Place one tick in each row of the table. As you see, we have in this side, we have volume, mass, density. We have three properties. We have decreases, increases, or stays the same. So the property of volume, what happens to the volume through expansion, thermal expansion, mass of the rod, density of the rod after expansion? The answer, so volume increases through thermal expansion, volume of the rod increases, and mass stays the same, mass does not change, density decreases. Now we know that density is equal mass over volume. We have inversely proportional between mass and volume. That's why when the volume increases, density decreases. Let us to see branch C suggests one disadvantage of thermal expansions. Now we have a lot of disadvantages of thermal expansion. We have to choose one of them. For example, it lets the electrical cables to be lower to the ground, or lets the telephone lines to be lower to the ground in a summer season. So we can choose any disadvantage of these. It is enough to list one of them. Now let us to see question number 14. See this question. And figure 4.1 shows a balloon near a window on a warm sunny day. Now in figure 4.2 shows how the volume of the balloon changes throughout the day. So in the x-axis, what do we have? We have the time of the day. Then in the y-axis, we have volume of balloon in centimeter cube. This is the graph to show the change in volume with throughout the day timing. Let us to see question number 1. In question number 1, what do we need? Describe how the volume changes throughout the day. Let us to see the graph again. See the graph. Now from the beginning until from 10 until 14, see how the graph increases. So the volume increases. This is until 14. Then after 14, the line goes down, so the volume decreases. So as you see, to describe the volume changes throughout the day, volume increases until 14, then volume decreases until 18. This is the answer of A. Now B. In B, explain in terms of gas molecules inside the balloon why the volume changes in this way between 10 and 14. Now, as you see, this question includes how many marks? Let us to see. It is 3 marks only. We have to list any 3 of these. You know that we can list that the temperature increases, temperature in the room or balloon increases, Also, the other idea, gas molecules move faster. And also this motion or this collagen is harder. We will have harder collagens or more yes, collagen between each other. And also the collagens result in a greater force on the balloon surface. So the gas pressure increases. So we have to list any three of these. Temperature increases during the day from 10 to 14. Then the gas molecules will move faster. The collagen increases between the air molecules and the surface of the balloon. This will exert more force, and this greater force will cause to have greater pressure. This is the idea of question B from this question. Let us now to move to question 15. In question 15, as you see, we need to explain in terms of molecules how thermal expansion takes place in a solid. So as you see, when they say in terms of molecules, we have to list only the ideas about in terms of molecules, not other ideas about thermal expansion. What happens to the molecules through thermal expansion in solids, not other ideas. We have a lot of ideas about this one. But since they said in terms of molecules, we have to list two ideas about molecules themselves. This is the technique to solve this question. So what happens to the molecules during thermal expansion in solids? Now, in thermal expansion, the temperature for sure increases. Now, when temperature increases, molecules gain more of kinetic energy. Now, when the molecules gain more of kinetic energy, they will vibrate more. Then when they will vibrate more, the spaces between them gets more. So the solid expands and increase in size. So as you see, when we have thermal expansion, temperature increases, molecules of a solid gain more of kinetic energy, so they will vibrate more. So they will start to push each other to increase the intermolecular distance, and this will help to increase the size of solid and to cause this phenomena of thermal expansion. This is the idea of this question. Let us to see the other branch of the same question. Complete table to show the relative expansion of equal volumes of liquid, gases, and solids. Choose words from much less, slightly more, much more. Now, in the first side, we have state of matter, liquids, and gases. In the second side, we have to choose the word that is suitable to compare liquids with expansion of solids for the same temperature range, and also the expansion of gases compared with the expansion of solids at the same temperature range. So which statement is correct for liquids? Let us see the answers. So I'll choose for liquids, the expansion of liquids is slightly more than the expansion of solids. So it's slightly more than the expansion of solids. For gases, I'll choose much more than expansion of solids. So these are the two suitable statements from the given here. Slightly more for the comparing of expansion between liquids and solids, and much more for the comparing of expansion between gases and liquids. And you have to remember here that the categories of expansion between solids, liquids, and gases, the highest in expansion, thermal expansion, will be gas, then liquid, then solids. But there is big idea about this one, that if we have the three states of matter at same time and they heat it up together, the first one will start expanding as solid, then liquid, then gas. But solids expand first but least. This is the big idea. Solids expand first but least. But in the general, the comparison in the general, gases, they are the highest expansion, then liquids, then gases. In the timing, which one will start first? Now, solids are first but least, then liquids, then gases. This is the idea of the question B from the question number 15. Now let us to see question number 16. See, in question 16, changes must be done to the design of the liquid in glass. So these changes are required for improving the thermometer in different areas. Now in I, they asked about what? Make the thermometer more sensitive. Let us to remember this idea. The features of liquid in glass and thermometers. Let us to start with the features. We said that most liquids expand slightly when heated. This property is put to use in thermometers filled with alcohol or mercury. So this is the idea or the scientific application of thermal expansion. Now the features. We said the first feature of liquid and glass thermometers is sensitivity. We said that narrower the tube and more the liquid inside moves, make the thermometers more sensitive to changes in temperature. Alcohol expands more than mercury, so a mercury thermometer must have a narrower tube than alcohol one. This is how to improve sensitivity in thermometers of alcohol and mercury. Look at the second feature, which is range. Now, mercury has a freezing point of 39 Celsius and a boiling point of 356 Celsius. Now, alcohol freezes at negative 150 Celsius, but boils at 78 Celsius. This is about range. Now, responsivity, the responsivity of thermometers, the thermometers with large bulb and thicker glass around the bulb respond less quickly to the change of temperature. Now, the last one, which is linearity. Now, in linearity, the expansion of mercury is not quite linear compared with alcohol. They differ slightly, but these differences are not significant between 0 Celsius and 100 Celsius. These are the features that we have to remember all the time when we're answering the questions about the features of liquid and glass thermometers. Now let us to see the answers of the question. Make the thermometer more sensitive. So I'll choose one of the improvement procedures, such as use thinner capillary tube. This is the answer of this one. So the second one, which is I2, give the thermometer a greater range. So we have a lot of procedures. We have to choose one. Why? Because we have one mark here only. So I'll choose one to improve the range of a thermometer. So the answer, I'll choose this one. You can choose other one. Use longer capillary tube. Use longer capillary tube. This is would improve the range of a thermometer, and use a thinner capillary tube would improve the sensitivity of a thermometer. Now the end of our session now. Here is the end of our session. What I'm suggesting is to stop the video and the starting of every question. Try to solve it alone. Then when we come to the answer, you can check your answer with the answer given in this video. To make this video helpful for you, so this is the procedure or the guideline to solve the questions from past paper 4. And remember, this paper is designed to test and to see the understanding and your knowledge in physics theory and your ability to apply the knowledge in the new situations. This is the all of the basic guidelines to answer this one. I tried to select some questions. You can also keep practicing all the time on other questions. This is the end of our session. Hopefully it was good and helpful for you. Thank you.